Okay. Silence, please. Okay. We first go through certain tricky points. They are not really tricky, but the places where you make mistakes. Okay. What is the square root of x squared? We just sort these things out, then we can start the problem. What is the square root of x squared? Simple, right? X. Hmm? Okay. Is it correct? Yeah, it's correct if x is greater than or equal to 0. If it's not, it's wrong. For example, take this one, minus 7 quantity squared, the square root of minus 7 quantity squared. So this 49, the square root of 49 is positive, it's 7. So it's not x. Therefore, you have to write mod x to ensure that it's positive. Numerically, they are the same, they have the same value. Both have the same value. But to ensure that it's a positive value, you need to introduce a modulus sign. And here, this one, x minus 1 quantity squared. Again, it's the same. Mod quantity x minus 1. What about the third one? When x is greater less than 2, what you can say is that x minus 2 is less than 0. Then what is it? You can, of course, write it as mod x minus 2. Since you know the range of x, in particular, you can write it like this. Now, x minus 2 is negative. With this inequality, you can see that x minus 2 is negative. Therefore, it's a modulus of a negative number. So you can multiply it by negative sign. So explicitly, you can write it as 2 minus 6. Because if you have a negative sign in mod, it's 7. You have to multiply what you have inside modulus sign by minus 1. Now, what about this? Again, with the same argument, x minus 2 is greater than 0. So you can write it as x minus 2. In this case, if you bring this minus 1 to the left-hand side, you get alpha plus 1 less than 0. Means what you have inside is negative. Therefore, you can write it as minus of what you have inside the modulus sign. So it's minus of alpha, quantity alpha plus 1 or minus alpha minus 1. What about this? Again, the case is the same. If you bring this 3 to the left-hand side, you get beta minus 3 less than 0. So what you have inside is less than 0. Therefore, the modulus, to get the modulus sign, you have to make it positive. So you have to multiply it by minus sign. Now, if you eliminate this bracket, you get minus beta plus 3. Right. Now, when I translated this, I didn't translate the last few problems because they are past paper problems, so you can get it from somewhere. Like those are the paper, like past paper questions, I think before 2015. The last 6 or 7 problems. I mean, no point of translating them because you can get them from somewhere. Right? Okay. We'll do the 32nd problem. Problem 32 in page 5. Here, a range for P is given. A range for P is given. Now, just to get the things more clarified, You can just draw it on a number line, but it's not necessary. It's not a must. But the range will be like this. It's between 0 and 2. But 0 and 2 are not included in the range. This part. And since it's mod P, you can have negative values as well. P can be, for example, -1. Still, this is 1. So you can go down to -2. So it's almost all the values from -2 to +2 except 0. Because you cannot have 0. Mod P is not equal to 0. So you have everything between -2 and +2 except 0. Right? Okay. Now, we need to show that this equation has real distinct roots. Real distinct roots means what? Delta should be greater than 0. There are 3 cases, right? When delta is less than 0, you have imaginary roots. When delta is 0, you have coincident roots. When it's greater than 0, you have real distinct roots. Now, in this case, you need to show that the equation has real distinct roots. So b squared minus 4ac. B is the coefficient of x. So b squared minus 4ac. Here you have 16 minus 4p squared. You can pull out 4. You get 4 minus p squared. Now that's delta. Now you need to show that this is greater than 0. You can start from this one. Mod p is less than 2 because that's what you need. If you square mod p, you get p squared. If you square 2, you get 4. So mod p is less than 2. Since it's an inequality and both sides are positive, because look, it's strictly positive. Even with 0, you can do that, but less than 0, then you cannot do it. Huh? If one side is less than 0, you cannot do it. Why not? Because, say, for example, if you have this one, -3 is less than 2. If you square this, you get 9 less than 4. So if you have a negative number in one side, usually it's not correct to, I mean, you can, sometimes you can get the correct answer like this. Here it's fine because why? What's the reason? Because this side, numerically, the modulus value is less than this one. But usually we don't square when one side is negative. In particular, in this case, you don't know what the value of p is. But in this case, since p is greater than 0, you can square. P squared is less than 4. You can, if you want, give the reason. Now, you can come up with this shape. You take this p squared to the other side. So that means delta is greater than 0. With this, if you plug in that, you get delta is 0. Sorry, greater than 0. The roots are real distinct. Roots are real distinct. They are different. I mean, they are not equal. So that part is over. Then, if the roots of this equation are alpha and beta, show that both roots are positive. Okay, this is the equation of our interest. Now we let the roots anyway. Roots are given as alpha and beta. We can find alpha plus beta. Minus of this value divided by 1, which is in fact 4. You can straight away write it as p squared. Now those are the values for alpha plus beta and alpha beta. Now you need to show that the roots are positive. To show that the roots are positive, you need to show that both of them are positive. Okay, what do you need to show if you want to show that the roots are negative? Both are negative. That means their product should be positive. If both are negative, this is positive, but this is negative. Now, in this case, you need to show that both are positive. Clearly, this equal to 4 greater than 0. Alpha beta is equal to p squared, which is greater than 0. Why? Mod p is greater than 0. Here you have to give the reason. When you square this, you get this one. Therefore, both alpha and beta are positive. It's not a big deal. No? First two parts are easy. Now you need to show that alpha minus 2 times beta minus 2 is p squared minus 4. Now you can expand. You get alpha beta. From these two, you get minus 4 alpha. This is minus 4 beta. And finally, you get minus 4 times minus 4, which is 16. Now we'll plug in the values, right? Alpha beta is p squared. This is 16. It's 2. I realized that something was wrong, but I didn't see this one. Sorry about it. Now, alpha beta minus 2 alpha minus 2 beta and 2 times 2 is 4. Now, when you pull out minus 2 from these two, and here you have 4, now you can plug in 4 for this one. This is 4. This is plus 4. So you get p squared minus 4. Yes. That part is also very easy. Now we'll go for the next. Now, this is getting worse now. Now you need to show that if alpha is greater than beta, deduce something like this. When alpha is greater than this part of the problem, not the answer. If alpha is beta, you need to show this one. Sorry, if alpha is greater than beta, you need to show this one. Now, how to start this? Look, earlier we have used the same thing. When 4 minus p squared is greater than 0. That means what about this one? P squared minus 4 less than 0. If you square both sides, you get this. So p squared minus 4 is less than 0. We need to show that one first. Then there are two cases. If this is negative, that means, okay, what does that mean? If this is negative, you have opposite signs. I mean, both attain opposite sides. If this is positive, this is negative. If the first one is negative, this is positive. There are two cases. So you have p squared minus 4 less than 0. Now for p squared minus 4, you can plug in this one. Alpha minus 2 times beta minus 2 is less than 0. Now you can start from there. Now you have a product which is which is less than 0. That means what? That means both attain negative signs, both attain different signs, opposite signs. If this is positive, this is negative. So assuming that this is positive, I mean, I'll provide more details. And these two go together. Beta minus 2. Now, if this is greater than 0, the other one should be less than 0. Or the other condition is that this can be negative, the first can be negative, and beta minus 2 is positive. Here you can, I mean, I'll provide more details just to make sure that everybody understands it, right? Now, alpha is greater than 2. You can bring that 2 to the other side, and beta less than 0. O, from this you can write alpha, not 0, 2. Alpha is less than 2 and beta is greater than 2. Now from this you can write alpha is greater than 2 and beta is less than 2. You can combine both inequalities. O, here, alpha is less than 2 and on the other hand, beta is greater than 2. However, if alpha is greater like this, if alpha is greater than beta, you cannot have this one because this is alpha less than beta. We have alpha greater than 2, greater than beta. Now the next one. Show that square root of alpha plus square root of beta is equal to something and square root of alpha minus square root of beta is equal to something else. Right? Okay, we'll do that. There's no direct way to find this one. Therefore, you get this Don't take this down now. Sometimes you may miss certain key points. Now, instead you take the square of this. Now, how do you square this? First, you take the square of the square root of alpha, which is alpha, right? Then you have to square this one, which is beta. I put those two together. Then the usual term in the middle. What's the term in the middle? 2ab term. It is 2 times square root of alpha times square root of beta. Even you can put those two together under one square root, right? I put it like this so that those two go hand in hand. It's easier to see what's going on. So this alpha plus beta, this is 2 times square root of alpha beta, the product alpha beta. Now you can plug in the respective terms for those. Alpha plus beta is 4 and alpha beta is p squared. This is 4. Right. Now what is this? Square root of p squared. P can be negative, right? If p is positive, you can straight away write it as just p. If p is positive. But we'll go and see what the range of p is. Look, p can be negative. Like if you have like this, like 0 less than p less than 2, then p is positive. Then you could have written it like this. Then the square root of p squared is p. But here p attains some negative values, right? Therefore, you cannot write it as p. Instead, you can write it as mod p. Right? Similarly, hold on. Now we have to get the square root. Now, square root of alpha plus square root of beta. Why don't you introduce plus or minus? What I wrote on the board is correct, but why don't you write plus or minus? Can it be minus? Look, a square root is positive. Square root itself is positive, at least non-negative. It can be 0 if alpha is 0. If not, it's it can be greater than or equal to 0. It cannot be negative. It's non-negative. This is also non-negative. So sum of two non-negative numbers cannot be a negative number. So this is also positive. Therefore, a negative sign is not necessary. It is always positive or 0. It is 0 if both roots are 0. But in fact, it is not 0. Look, their product is non-zero, greater than 0. They are positive. We proved that they are positive. Therefore, both are positive. Therefore, each piece is positive. Therefore, the sum is positive. So, introducing a negative sign is in fact wrong. Otherwise, you have to do that. Here, you don't have to. Then, in the similar fashion, you can find the square root of alpha minus the square root of beta. Like this. It is alpha, the square root, sorry, the square of this is beta, but the usual term in the middle, 2ab, but it's a negative sign, minus 2ab. 2 times square root alpha, square root beta. You can write them under 1 square root. Now plug in the values. 4 minus 2 times the square root of p squared. Again, with the same argument, you get mod p. Now you get the square root. Here, again, I didn't write plus or minus. Why? Because we know that alpha is greater than beta. It's given in the hypothesis, alpha is greater than beta. Therefore, square root alpha is greater than the square root of beta, since both are positive. Make up 9, if it is 9 and this is 4, the square roots are 3 and 2. It's always greater. Therefore, this is positive. You don't have to introduce a negative sign there. Now we need to find the equation with these two as the roots. I guess we'll see. Mod, there's a modulus sign. Okay. Now, how do you find this equation? X squared minus the sum of the roots. This is the first root. This is the second root. So sum of the roots appears there. Now you have this, the product. After that, how do you proceed after this point? Now look, we have this. Alpha is greater than 2 and 2 is greater than beta. If you compare these two, which one is greater? Square root alpha or square root of 2? Which one is greater? Square root of alpha is greater. Therefore, this is positive. So since it is positive, as I told you earlier, this should be equal to square root of alpha minus square root 2. What about the second? This one. Which one is greater? 2 or beta? 2 is greater. Therefore, if you compare these two, square root of beta is less than the square root of 2. Therefore, this is negative. Therefore, when you take the modulus of that, you have to multiply the inside by minus 1. So it will be square root 2 minus square root beta. But we have done our homework. When you do the homework, is not the homework I have assigned. Now we have done everything beforehand. Like when something appears here, we know what it is. Right? Now, this one. If you want, you can multiply them out, or you can take each piece. What is this? Modulus of alpha minus, sorry, modulus of the square root alpha minus square root of 2. Which one is greater? Square root of alpha is greater. With the same argument. So this is square root alpha minus square root 2. What about the second one? Here square root 2 is greater. Therefore, it should be now. What you have inside is negative. Therefore, you have to multiply it by another negative sign to make it positive. Now that's it. Now these two will go away. square root alpha minus square root of beta plus we'll multiply them. Here you get square root 2 square root alpha. Here square root of alpha beta. I'll write it under 1 square root. Now when you multiply these two, you get minus 2. When you multiply these two, you get plus square root 2 square root beta. Don't worry about this part. We'll later plug in what we have obtained an expression for this here. It's here. But we'll wait. We have to figure what this is. Now you can combine these two. So square root of alpha beta minus square root of alpha beta, we have it as the first term. This is minus 2. Now from these two, you can pull out square root 2. So inside you get square root alpha minus square root beta. Now you have that up there. Now let's plug in the respective expressions. This one is the square root of 4 minus 2 times mod p. This one times x minus, now what is this? Alpha beta. We have found it somewhere. Look here. It's p squared. So it turns out to be the square root of p squared minus 2 plus square root 2. Now we have obtained an expression for this one. It's square root of 4 plus 2 times mod p. Now we have to write one more line. What is this? Square root of p squared. P can be negative. Huh? Therefore, it should be mod p minus 2 plus square root 2 times. Okay. Okay, you take that down. Then I'll give something similar. Right. Okay. Here in the tutorial, it's given as square root 8 plus 4 would be. We can, like both are square roots. So you can write them under one square root. Now you can write them under one square root. That means you have to multiply these two. When you multiply this by 2, you get 8. When you multiply this by 2, you get 4 mod p. Okay, after copying this down, do the 33rd problem. Again, this is very similar to the previous one. You find delta and you can factor out 4, which leaves 1 minus k squared in the bracket. Now, since mod k is less than 1, you can square both sides. And you can do that because mod k is greater than 0. If this side is not greater than 0, you cannot do it. At least it should be greater than or equal to 0. So just right after that, you can take this to the other side. So this implies 1 minus k squared is greater than 0, means this bracket is greater than 0. Therefore, delta, the discriminant, is greater than 0. It implies that the equation has real distinct roots. So first part is done. No, so you do the rest. Okay. After that, the roots of this equation are given as alpha and beta. We need to show that they are negative. Both of them are negative. So before that, we need to find alpha plus beta and alpha beta. This is minus 2 over 1, which is minus 2. Alpha beta is C divided by A. Now, to show that both are negative, negative means they have the same sign. So alpha beta should be positive, same sign. Since both of them are negative, when you add two numbers, it should be negative. So we have to show that this is negative and this is positive. Clearly, this is negative. Huh? And alpha beta is k squared, which is greater than 0 because it's given like that. Mod k is greater than 0. Therefore, when you square this, you get this. Therefore, both alpha and beta are negative. Oh, both roots are negative. That would be enough. Negative. After that, we need to show that alpha plus 1 we need to come up with an expression for this. So we'll expand alpha beta, then alpha times 1 is alpha plus beta plus 1. Here alpha beta is k squared. Alpha plus beta is minus 2 is plus 1, which is k squared minus 1. Now we need to show that if alpha is greater than beta, we need to deduce that alpha is greater than minus 1 and it is greater than beta. So we need to know what the sign of this is. Since mod k is less than 1, when you square this, you get this. So k squared minus 1 is negative. Since k squared minus 1 is equal to alpha plus 1 times beta plus 1, this product is negative. That means they need to have opposite signs. So there are two cases. Either alpha plus 1 is greater than 0 and beta plus 1 less than 0. One is positive, the other one is negative. Or the other possibility is that this is negative and this is positive. Alpha plus 1 is less than 0 and beta plus 1 is greater than 0. This says alpha is greater than minus 1 and minus 1 is less than beta. You can take, it's wrong, other way around. And, O, again, you can do the same thing. Alpha is less than minus 1 and beta is greater than minus 1. So from this, you get alpha is greater than minus 1, which is greater than beta. O, alpha is less than minus 1 and beta is greater than minus 1. That's not necessary. Now, there are two cases. Since alpha is beta, this cannot happen. No? Last time I didn't include that step. Therefore, this cannot happen. Therefore, you get this. So we are done with that part. Now we need to show that alpha minus beta is 2 times the square root of 1 minus k. Alpha minus beta. We'll find the square root. Sorry, square of this. It's not very similar, but there are these two share common terms, right? These two share alpha squared, these two share beta squared. Here you have minus 2 alpha beta. In the right hand side, you have plus 2 alpha beta. So if you subtract 4 alpha beta, these two are equal. So alpha plus beta is, we have found it somewhere. Here, minus 2. Alpha beta is k squared. So this is minus 2. Is k squared. So this is 4 minus 4k squared. Now, mod k is less than 1. Therefore, this is positive. Then you can find alpha minus beta. If you get the square root, since alpha is greater than 0, you can write it like that. Square root should be positive. Or I can do it like this. So take the square root of each piece in the right-hand side. These two. Since k squared is less than 1, you can write it like this. You can give the reason. And in the left-hand side, alpha is greater than beta. Therefore, you can straight away write like alpha minus beta. Right. You can even include the reason here. Now, we need to show that alpha plus 1 plus beta plus 1. Sorry, mod alpha plus 1 plus mod beta plus 1 is right. It is equal, we need to show that it is equal to 2 times square root of 1 minus k squared. So you can probably recall this one. Alpha is greater than minus 1 and it's greater than beta. So that means alpha plus 1 is positive. So the modulus is just the same. But here, if you compare these two, if you bring this minus 1 to this side, beta plus 1 is less than 0. I'll write it like this. If you compare these two, alpha plus 1 greater than 0. And if you compare these two, if you bring this minus sign to the other side, so this guy is positive. So its modulus is the same. But here, what you have inside is negative. Therefore, you have to multiply it by minus sign. So this plus 1 and minus 1 will go away, leaving alpha minus beta as the answer. Now you need to show that the quadratic equation with roots, alpha, with these two as the roots. You can start with x squared, insert the sum times x plus the product. Now you know what it is, because we have just obtained what it is. And we know that alpha minus beta is this one. So we have done the homework pretty much, because we exactly know what they are. Now we need to figure this one out. So it is x squared minus this alpha minus beta x. Now this is alpha plus 1 minus times alpha plus beta plus 1. So this is 2 times the square root of 1 minus k squared. This entire thing is minus because of this negative sign. Then multiply alpha beta. You have this one. You have what this is. We have found it somewhere. Alpha plus 1 times beta plus 1. Right there. Right. So it's k squared minus 1. Okay. You can take that down. Okay. Range of a quadratic function. We can take the function in its general form. So ax squared plus bx plus c. When you square this, first you get x squared, then you have 2kx plus k squared. So if you take these two terms, like you can, using these two terms, you can reduce this one. Look, take what you have as the first term, get the square root. Here the constant is, or the coefficient is 2k. You divide it by 2, so it will be k. From this you can get this constant. Now I mean, we did something like this when we obtained the quadratic formula. So this one is very similar to that. So basically, you cannot complete a square when you have some coefficient other than 1 as its coefficient. I mean, the coefficient of x squared other than 1. So you make it 1. To do that, you pull out a. When you pull out a factor, you have to divide everything by that value. So here, when you pulling it out, it will be x squared. You have to divide it by a. So it's b over a times x. And this is c over a. Now, using these two, you complete a square. Like you did, I mean, like we observed here. So introduce a square bracket. Now you can express these two so that they are in the square. So you write the square root here. The square root of x squared is x. Divide this number by 2. So you have b over 2a. Now the first two terms of this function are taken care of this square. Look, when you expand this, you get x squared. What's the 2ab term? 2 times this times x. So 2 times this one is b over a times x. So it's there. But you have an extra term. That is this k squared. Or in this case, it's b squared over 4a squared. You have an extra term here, which was not there earlier. So you cannot just introduce extra terms. So you have to cancel it. So you have c over a. You had already there. I mean, you have it there already. Now you subtract this one, the square. The square of this guy is b squared over 4a squared, because everything is a product or division. So you can square each piece. So you have b squared over 4a squared. Now you can combine those two. Now x is only in one place, so it's x appears only in one place. Take the common denominator, which is 4a squared. You multiply this guy by 4a to make it 4 squared. Do the same thing to the upstairs. You have this. We are little familiar with this. What is this? B squared minus 4ac is delta. Right? Let me write it here. Now, what is this? It's a minus of that. So it is minus delta. So you can write it like this. Now, eliminate the square root, sorry, the square bracket. So you will end up with this. When you multiply these two, this a will go away with the square. One of these a's, right? So you get delta over 4a. So that's how you write it, like express this so that x only appears in one place. Now using this, you can find the range. There are two cases. The first one is when a is greater than 0. The second case is when a is less than 0. Because you have, I mean, in O levels, in the graph, the problem from graphs, you get something like this. When a is greater than 0, you get a cup like this, a graph like this, like a cup. When a is less than 0, you get a cap like this. Right? මෙවනින් graph එක negative වුණා නම් මේ වගේ එකක් එන්නේ. මෙතන a positive වුණා නම් මෙහෙම එකක් එන්නේ. Volumes වල හැමදාම මේක එනවා. Right? Okay. So in this case, when a is greater than 0, okay, this is what happens. Okay, let me do it like this. Rather than okay, I'll do it like this. Huh? Okay. For all real values in R, sorry, for all x in R, you can start to fit this one. Would make a square of x x only appears in this bracket. So x plus b over 2a quantity squared is a square, therefore it is greater than or equal to 0. Right? This is a perfect square, and these are real numbers. So the square of this number is greater than or equal to 0. It cannot be negative. If it's complex, you can have negative values, but otherwise you get something non-negative. Now you need to multiply this by a. That's where you need this. There are two cases. When a is greater than 0. The other case is when a is less than 0. When a is greater than 0, you multiply both sides by a. So this side is 0. 0 times a is 0. However, since a is positive, the inequality remains intact. Positive number the inequality reverse right? So you can keep it intact. But here, when a is less than 0, when you multiply something by a negative number, take this one for example, 7 is less than 10. But when you multiply this by a negative number, you get minus 7 and minus 10 in two sides. Now minus 7 is greater. Because in the number line, minus 7 is sitting to the right-hand side of minus 10. Minus 10 comes first. Then minus 9, minus 8, minus 7. So if you compare these two, minus 7 is greater. So here the inequality should be reversed. So when you multiply something by a negative number, the inequality should be reversed. So you get this. Right-hand side, you get 0. However, this should be reversed. Now you need to add this one. In fact, subtract this one. That will be equal to fx. Here, sorry, it's wrong. I subtracted this one, so I have to subtract it from both sides. Here also I do the same thing. I subtract delta over 4a from both sides. Now what is this? This is fx greater than or equal to minus delta over 4a. This is fx, which is less than or equal to minus delta over 4a. Now you can come up with the range. Now look, fx can be anything greater than or equal to this. Say, for example, this is 100. So if this is 100, this can be something like 101, 102, 2000, 1 million, or whatever. But the least number you can have for this fx is 100. Because this is 100, fx is greater than or equal to 100. That means fx can attain any value other than 100 and 100, sorry, all the values greater than or equal to 100, and the smallest value it can attain is 100. So f min is this one, right? That's the minimum value. Similarly, in this case, fx is always less than or equal to this one. So the maximum value fx can attain is this, right? So it is f max. If I want to indicate it using a graph, like in the first case, you get something like this, where this is the minimum value. It is minus delta over 4a. Or you get something like this. Let me shift it towards this side. Now it has a maximum value, which is again delta over 4a. This is for the case where a is greater than 0. This is for the case where a is less than 0. Right. You take that down, then we'll do an example. Okay, we'll do 60. Right. In 60, fx is given where B and C are real numbers. 1 plus B plus C is greater than 0. Now, there are few parts. We need to show that 1 is not a root of the quadratic equation fx equals 0. The quadratic equation fx equals 0 is this. Now, we need to show. Now, we need to show that 1 is not a root of this equation. If 1 is a root, it should satisfy the equation. So eventually you will end up with a plus b plus c is equal to 0. However, it's given that in the hypothesis, 1 plus b plus c is greater than 0. So this is a contradiction. Therefore, 1 is not a root. So we are done with that part. Now, if alpha and beta are the roots of fx equals 0, so this is the equation. If alpha and beta are the roots, we need to find alpha minus 1 times beta minus 1. So first we need to find alpha plus beta as well as alpha beta. This is minus b over 1, which is minus b. This is c over 1, which is c. So alpha minus 1 times beta minus 1 is equal to, you can expand this alpha beta minus alpha, then minus beta plus 1. You can pull out minus sign from these two. You get alpha plus beta in the bracket. Now plug in the values. Alpha beta is c. This is minus b. This is plus 1. So it is 1 plus b plus c. Now we need to find the equation with roots. 1 over alpha minus 1 times 1 over, and 1 over beta minus 1. Is, you can start with x squared minus the sum of the roots times the product of the roots. Now you can take the common denominator in the of the term in the middle. If you do that, you will end up with beta minus 1 plus alpha minus 1. Now you can multiply everything by alpha minus 1 times beta minus 1. Neither of them is a root, it's 1, because the roots are not equal to 1. Therefore, this is not equal to 1, this is not equal to 1. So alpha minus 1 times beta minus 1 is not 0. It's given that it's greater than 0. Therefore, you can multiply. Here you get alpha plus beta minus 2. The last term will be 1. Now let's plug in the respective terms. This is 1 plus b plus c. Alpha plus beta is minus b. So you get explain කරද්දි කතා කරන්න එපා. සිංහල ඉක්මන එකපාර. හරිද? අහන්න බැරි නිදා ගන්න. හරිද? ඒකට කවන්නේ මේ කතා කරන්න එපා explain කරද්දි. හරි? ඒක අහන්න උනා ඉන්නෝනේ. අහන්න උනේ තේ නිදාත්තර කවන්නේ කෑ ගන්න එපා. හැබැයි මේක කොපි කරනකොට කෑ ගහවට කතා කරන්නට කවන්නේ. එහෙම අවුලක් නැහැ. අනිත් ඩිස්ටර්බ් වෙන හින්දා එහෙම කරන්න එපා කිව්වේ. Right. මට ප්‍රශ්නයක් නැහැ. මට ඩිස්ටර්බ් වෙන්නේ නැහැ. Right. Okay, this is the equation we get. However, we need to state the answer like that. Okay. We need to show that the quadratic equation is in the form of gx equal to 0. Right? Now you can say that. Okay, this is given by gx is equal to 0, where now we have to mention what gx is. Gx is this, the left-hand side of this equation. I have to return to this space. Hold on. Right. Plus b plus 2 times x. So this is gx, right? Now, by completing the square, we need to show that the minimum value of fx is minus delta over 4. Now, it's very similar to what we did earlier, right? Now, again, recall fx. But this is little easier than that because a is 1. So we can complete a square straight away. Write the square root of the first term. Write the half of the coefficient of the second term, b over 2. So the first term will be x squared. 2ab term will be bx. Then you have an extra term here. The square of this is an extra term. So subtract. That square is b squared over 4. Now you can write this under, above one common denominator. You get 4c minus b squared. However, in this case, delta is b squared minus 4ac. b squared minus 4 times 1 times c. So it's this. So it means this is minus delta. Right. Now, you have to go through this argument. Now, for all real values of x, or at least for x is in R, you can write this square, which is greater than or equal to 0. Now subtract delta over 4 from both sides. Now this is fx, because we have shown that fx is equal to that. Oh, fx can be expressed in this form. Therefore, this is greater than or equal to this. That means the minimum value of x is this. Right? So we are done with that. Now, also show that the minimum value of gx is minus delta over 4 times 1 plus b plus c. Now, it's difficult. Now, this is the catch, right? Now, in this case, you cannot complete a square. It will be extremely difficult. You can do it, but it's difficult. First, because you need to pull this out. Then you have to divide these constants by 1 plus b plus c. So it is little difficult. Then what should we do? But here there's a little problem, because in this case, we don't have an A. But we can use the result we had earlier. We'll use that one. Okay, what's the minimum value of this one? Since this is greater than 0, you have a minimum value. So since gx has a minimum, here we cannot extend this one to the general form, because here A is equal to 1. Right? If A is not equal to, say, we had some A, then you can, instead of A, you can write 1 plus B plus C. Therefore, we'll use the general result here. G min is what? Delta over 4A, right? That's what we had earlier from the previous case, not from this problem. Make a problem, make a put work. We cannot generalize this result. Make A you could have replaced A by 1 plus B plus C. Right? Okay. Instead, I could have done 61. 61 a problem. You can generalize that result for Gx. So let's use this one, what we had earlier. It's very similar to this one, but here, since A is 1, you get minus delta over 4. Then delta A, 4A. Right. So we'll find delta here. Let's write delta. Let me write Gx first. Gx is this 1 plus B plus C x squared plus B plus 2 times x plus 1. So the problem is to find delta. Delta may be something different. We'll see. If we find delta, let me write G here. So B squared minus, or delta 1. B squared minus 4AC. So we have to start off with B plus 2 quantity squared minus 4. A is this. C is 1. We'll expand this. B squared plus 2AB term is 4B plus 4. Then minus 4 minus 4B minus 4C. Look what happens. These two will go away. These two will go away as well. So you get B squared minus 4C. What is B squared minus 4C? B squared minus 4C is the delta of fx, right? Because A is 1, therefore this delta. Because in this problem, it's given that delta is equal to B squared minus 4C. The line before the last, you have that for this particular problem. So this is delta. Yeah, this should be delta 1. No? The discriminant of the function g minus of that divided by 4a. Now, if you apply that result, you can write g min minus delta over 4a. But in G, A is 1 plus B plus C, right? The coefficient of x squared is, where is it? G, okay, here. The coefficient of x squared is usually considered as A. So A is 1 plus B plus C. So for this particular function, it will be minus delta over 1 plus B plus C. The specialty is that here, for f and g, for both functions, the discriminants are the same. Delta 1 is delta. So here, instead of delta 1, you could have written delta over 4 times, but instead of A, you have 1 plus B plus C. Yeah, but I have imported this from the theory. Making generalized current wave, A is not, A is 1. If A is not equal to 1, I could have done it. ඒක මේක problem put deficiency එකක් 61 එක කරන්න හරිම I forgot it. Okay, copy that down, and after that we'll do 2000. The problem appeared in 2016 paper, which is problem 98. I'll write G in here. It's a matter of plugging in the respective values to this one. when you're doing this problem, you don't have to copy this down. No? You have the singular version in the tutorial. You can just read that. If you don't understand something, you can get it from this one. I have translated the last few parts. Since I don't have enough space for that, I'll wait till you copy this down. Then I'll erase this part and uh, write those two sentences. Right? Don't take this down. No? You can just, if you need some help, you can go through that. Otherwise, to straight away do the problem. Yeah, I could have done 61. You see, there's a little problem in translating the minimum of fx to the minimum of gx. Anyway, you can do it in 98. Since I was in a helpless situation last time, because last time from fmin you cannot reduce gmin, because f is a special function where a is equal to 1. Therefore, I have imported this one from theory. But usually you are not supposed to memorize these things. Therefore, this time when you do this problem, you can get the minimum of gx using the minimum of fx. Making Gandipa. Memorize කරන්න නේද? ඒක තමයි දැන් memorize කරන එක advantage එකක් නෑ. You can get information from anywhere. I can interneting hurry. You can ගන්න sources තියෙනවා දැන්. But like 30 years back, there are no enough sources. Therefore, it's better to memorize things like that. But now you're not supposed to do that. I don't know. You're not supposed to be strong. You're not expected to do that. Right? Therefore, it's better to avoid those and get that answer from what you have obtained in the previous steps. I hope. Here the minimum value of fx is m1. Then I erase this part. No, no, you don't copy this down, no? You can just use the problem appear in 98 as problem 98. But if you don't understand something, you go through this one. Now, Manam Pamanakken if and only if. It should work for both sides. we need to show that 1 is not a root. Yeah. So assuming that 1 is not a root, you can come up with a contradiction. So this is the equation of our concern. So if 1 is a root, it should satisfy the equation. Now a plus b plus c is 0. But this is a contradiction because it's given that a plus b plus c is greater than 0. Now assuming that the roots of this equation are alpha and beta, we can find alpha plus beta, which is minus b over a. Alpha beta is c over a. Now you can find alpha minus 1 times beta minus 1. C over A, this is minus B over A, and this is 1. You can write everything above one common denominator, C plus B plus A. Right? That part is straightforward. Now we need to find the equation with roots alpha minus 1, sorry, 1 over alpha minus 1 and 1 over beta minus 1. Multiply everything by alpha minus 1 times beta minus 1. Now plug in what you have here. I'll write A plus B plus C. My plus, no, this should be minus. Alpha plus beta is minus B over A. If you multiply everything, oh, this is, now this negative sign will make everything positive. When you take A as the common denominator, this will be 2A. And when you multiply everything by A, let me insert A there. Now multiply everything by A. Now, we need to find the minimum of fx. It's very similar to the theory. Now, fx is this. So before completing a square, you have to make this one, you have to pull out a, so that the coefficient of x squared becomes 1. Now complete the square inside the bracket. Write the square root, divide the coefficient by 2, get the squares. Now you have x squared, 2ab term will be 2 times this is b over a times x, but you have an extra term here. You have to subtract it. For the equality, you have to subtract that for the cancellation. So when you square this, you get b squared over 4a squared. Above one common denominator, you can write it like this: 4ac minus b squared, which is minus delta. Now multiply this. When you multiply these two, you get 4a in the denominator. This is minus delta. Now it's given that a is greater than 0 and a plus b plus c is also greater than 0. That means the coefficient of x squared of fx is greater than 0 and this is also greater than 0. That means both what? Both have minimums. X squared coefficient greater than 0 na minimum එකක් එන්නේ. ඒක තමයි දැන් force කරලා තියෙන්නේ a greater මෙතන ඉහාට problem එක තියෙනවා. A is greater than 0 as well as a plus b plus c is greater than 0. Now since a is greater than 0, you can multiply this one by a. So the inequality remain intact. Arcus a only very 0. Now this is this. Okay. After that, you subtract minus delta over, subtract delta over 4a from both sides. Now this is fx. Therefore, if mean, which is in fact m1, is minus delta over 4a. Now you have to do the same thing for g. How would you do that? Now, don't try to complete a square. It's extremely difficult. Now, this can be extended. In the previous problem, there's a little deficiency in the problem. Now, here, you can extend it because what you get is minus delta over 4 times the coefficient of x squared. Now, this is more general. Now, find delta 1 for g. So delta 1 is b squared minus 4ac. B stands for the coefficient of x. Minus 4 times this times a. I'll expand this. You get b squared plus 4ab plus 4a squared. This is a 2ab term. 2 times 2a times b is this. When you square this, you get 4a squared. Now, if you eliminate the parentheses, you get bracket, you get 4a squared minus 4ab minus 4ac. Now, these two will go away. As well as this pair, leaving b squared minus 4ac, which is in fact delta. Now, you can extend the same result. Now, G min can be identified as minus delta 1 over 4 times, instead of A, in the place of A, you have to plug in A plus B plus C. Because here, look, the coefficient of x squared is A plus B plus C. Now, delta 1 is delta. In fact, G min is M2. I'll insert that as well. G min is M2. Now, delta 1 is delta. Now, that's what we get. Now, we need to show that M2 times, this one, M2 times A plus B plus C is M1 times A. I hope you can remember this while you erase this part. This is, okay, this says that for all values of x, if gx is greater than or equal to 0, if and only if fx is greater than or equal to 0. I'll tell you what it is. Now you have to come up, you have to connect these two. Now from 1, you get minus delta. Straight away you can do it. From 1, you get minus delta is equal to 4a m1. From 2, you get minus delta is equal to, when you cross multiply these two, 4a plus b plus c times m2. So from these two, you can make these two equal. So this is 4a m1 is equal to 4 times a plus b plus c times m2. These two will go away. Or you can divide. That's also another way of doing this. You can divide this by this. You can get rid of minus delta so that you can come up with this connection. Now the last thing, last one. Say, for example, how many points? 90 points are allocated for this problem. Now we are left to do the last part. Say you have no clue of doing how to do. So what should you do? This part is relatively easy. You can easily show that 1 is not a root. You can easily show this one. You can easily come up with this one. And even you can find the minimum of fx. That's also not difficult. If you extend the same idea, you can come up with this one, the minimum of g. After that, probably you might have little difficulty with this, but it's also not difficult. Say you got stuck in this one and the last one. What should you do? Say nearly 90 points are allocated for this one. Probably you are missing out 10 points. If you have come up with this one up to this point, probably you are missing out 10 points. 80 out of 90. 80 out of 90 means 89 points, 89%. So you can leave it. 89 is not bad. Nearly, less than 1% of students score more than 89. But usually students do it like this. If they score nearly 89%, always they think that, oh, I didn't do this quadratic equation problem. I couldn't get it done. That's what people usually, that's a feeling they usually have. ගොඩක් ස්ටුඩන්ට් කෙනෙක් හිතන්නේ පේපර් එකේදී 1 ඉවර කරන්න බැරුණානේ. ඒ කියන්නේ 1 කරේ නැහැ. එක්කෝ එකේ භාගයයි කරේ. I have gone through just, I have just done half of the problem, or part of the problem. ඒතර භාගයක් කරා කියලා තමයි කියන්නේ. ඒතර ඒ mentality එකකින් you start the second problem. Say if you get stuck in the second problem as well, then what happens? එකක්වත් කරගන්න බැහැ. half තියෙන්නේ. ඊට පස්සේ ඉතින් එහාට upset කරගන්නවා. එහෙම නැත්නම් the other way of getting, through the things of this, what you need to do. You keep doing the last two parts. You keep on trying these two. Then waste nearly 25 minutes. Then you look at those, wow, one now is gone, now you're done. I'm done with the paper. So after that, you get like scared. The bio feeling එක ආපු ගමන් adrenaline level ඊට පස්සේ blood flow කියන්නේ කකුල් දෙකට අත් දෙකටයි. කියන්නේ fight or flight. දුවන්න කකුල් දෙකට fight කරන අත් දෙකට කකුල් දෙකටම මුලට ලියන්නේ නැහැ එතකොට. ඊට පස්සේ බය වුණාම ඔලුවට මුකුත් දෙන්නේ නැහැ blank කියලා paper එක බඩු fail. essay කරි මොකක් හරි එනවා. ඒතර ඔයගොල්ලෝ කරන්න ඕන දේ තමයි බය වෙන්න එපා. මේකේ 89% කරලා තියෙන දැන්ට. forget it කියලා ඊගාවට යන්නදී. යද්දි feeling එකක් තියෙනවනේ මං මේ problem එක ඉවරයි කියලා. But leave some space. I will try කරන්න. එහෙම කරන්න. මේක try කරන්න එපා. If you get stuck, forget it. You do the second problem. එහෙම කරන්න. paper එකේ එහෙම තමයි smart, that's a smart way of doing it. මේකට ඉඩ තියන්න හැබැයි. වෙලා තිබුණොත් ඇවිල්ලා කරන්න. Otherwise, but usually 99% of students approach the other two. They go ahead with the other two approaches. බලන්න ඉතුරු කැල්ල කොහොමද try කරලා විනාඩි 25ක් විතර කරලා time එක ඉවරයි ඊට පස්සේ. හරි. ඒක එක method එකක්. paper එක upset කරගන්න. second method එක තමයි මේක කරායින් පස්සේ feeling එක කරගෙන යනවා පළවෙනි කරන්න බැරුණා. වැඩක් නෑ ඉවරයි කියලා යනවා second එකට. ඒකට මෙතනට එනකොට 89% score කරලා ඉවරයි. අවුලක් නෑ. හරි. මේ last two parts තියෙන අර උඩම ලකුණු වලට යන අයට. හැබැයි මෙතන ඒක කරන්න පුළුවන් අය ඉන්නවා. නේද මේ ඒක කරත් යන තත් එක. ඒක නැති බ මෙතන. You need just 75 marks to get selected for engineering. 80 වගේ තිබ්බොත් පෙරදින මුරට පුළුවන්. 85 වගේ තිබ්බොත් ඉතින් district rank 20ට වගේ ඉන්න පුළුවන්. 85 වගේ තිබුණා. 95, 92, 95, 92, 93 වගේ තිබුණොත් island rank අර පළවෙනි 10ට ඉන්න පුළුවන් සාමාන්‍යයෙන්. first 10 ඉන්න පුළුවන්. හැබැයි maths ඉතල තිබිලා බෑ. chemistry හොඳට තියෙන්න ඕන. Right. Okay, now we'll see how to do the other part. Okay, this is the last part. You have to show that when fx is greater than or equal to 0, for all x in R, if fx is greater than 0, fx is greater than 0, if and only if. If and only if කියන්නේ දෙපැත්තටම පෙන්නන්න ඕන. Okay, නම්ම පමණක් කියන්නේ if and only if කියන්නේ you have to, if fx is greater than 0, you have to show that gx is greater than or equal to 0. And if gx is greater than or equal to 0, you have to show that fx is also greater than or equal to 0. How can you do that? ඒක අමාරු එක තමයි ලීසි section එක මේක ඇත්තටම. Right. Because දැන් මේක තියෙන මොකද තියෙන, why did you prove this one? මේක පුල් ගන්න නෙමෙයි මේක කරේ මොකක් හරි වැඩකට. Right. Now, okay, let fx is greater than or equal to 0 for, okay, listen to this, for x in R. Again, ඔක්කොම real values වලට fx is greater than or equal to 0. You can make, what can you say about the minimum value of this? Minimum value, make a one not pull minimum value should be greater than or equal to 0. That means M1 is greater than or equal to 0. Making, A positive, make a positive, A is greater than 0, this is also greater than 0. Make a positive, make a positive, make a positive. What can you say about M2? M2 is also positive. Because it's given that in the problem, it's given that A is greater than 0. A plus B plus C also greater than C is also greater than 0. Now, if you assume that M1 is greater than or equal to 0, this cannot be negative. So, M2 is also greater than or equal to 0. reason is A is greater than 0, A plus B plus C is greater than 0. Now what can you say? If M2 is greater than 0, that means the minimum value of Gx is greater than 0, therefore Gx is also greater than or equal to 0 because Gx is greater than or equal to M2. Only him insert current like this. Fx මේකට වැඩි හරි සමානයි equal. Therefore M1 is greater than or equal to 0. Therefore M2 is greater than or equal to 0 from this relationship. Therefore, if M2 is greater than or equal to 0, Gx is like this. Therefore, Gx greater than or equal to 0. And this works in the reverse direction as well. This implies this one, this implies this. And if you go in the reverse direction again, it implies that. You don't have to rewrite it again. I mean, rewrite it. Huh? With this one, you can prove this one. Therefore, this. You can go in both directions. We're going to 5 marks. ගැන පේපර් එකේ ෆීලිං එක තමයි වැදගත් වෙන්නේ. මම එක් කරා කියලා කිව්වොත් වෙනස්. මම එක් කරේ නැහැ කිව්වොත් තව එකක්. You always look at the things in. You can try 61. Hold on. You can try 61 as your homework problem. 61. Right. Because fx is greater than or equal to 0. This can be even 4. Minimum value can be 4. It doesn't matter. With this, you know, since M1 is greater than or equal to 0, with this setup, M2 is greater than or equal to 0. So Gx is even greater than or equal to M2. So that means Gx is greater than or equal to 0. The simplification like this. This implication like this implies second one implies third one, fourth one, fifth one, and you can go in the reverse direction as well. Therefore, you don't have to rewrite it. If and only if the beta Haryana. Right. We need to go through a little like common roots. Having a common roots. We can do that part and we can start limits next week.